A meso compound is a compound that has chirality centers but is achiral. We're going to come back to this definition in a few minutes. Right now, let's focus in on this drawing, and our goal is to draw all possible stereoisomers for this dot structure. So we know from earlier videos that this carbon is a chirality center, and so is this one. And we would expect 2 to the n stereoisomers, where n is the number of chirality centers. And since we have 2 chiral centers here, we would expect 2 to the second power, or 4 stereoisomers. So this is really just a maximum number, so I'm going to put a question mark right here. So do we get 4 stereoisomers? Well, let's draw out the 4 possibilities. Our first stereoisomer could have both bromines coming out at us in space. So let me go ahead and draw that in. So we could have both bromines coming out at us. For the second possibility, we might have both bromines going away from us in space. So I'll draw that in there. For the third possibility, we could have 1 bromine up and 1 bromine down. So I'll put those in. And for the fourth, just reverse them. Have the top bromine down and the bottom bromine up, like that. Alright, let's examine the relationships between our stereoisomers. And let's start with stereoisomer possibility 3 and 4. So let's compare these and let's figure out the relationship. On the left is stereoisomer 3. We can see there's a bromine coming out at us and a bromine going away from us. On the right is stereoisomer 4. Now we have a bromine going away from us at the top carbon and a bromine coming out at us here. So let's compare our 2 stereoisomers. If I rotate the one on the right, we can see these are mirror images of each other. And if I try to superimpose one on top of the other, here we get one pair of bromines to line up, but the other pair doesn't match. If we try to get the other pair of bromines to line up, now the first pair doesn't match. So these are non-superimposable mirror images of each other. These are enantiomers. So 3 and 4 are enantiomers. They are non-superimposable mirror images. And we could have guessed that by looking at the drawing, because at this carbon we have bromine coming out at us in space, and then now we have bromine going away from us in space for the other stereoisomer. So that's an opposite configuration at that carbon. And at this carbon we go from a dash to a wedge. So that's an opposite configuration at this one too. So since we have opposite configurations at all chirality centers, we would expect these two to be enantiomers of each other. What about the relationship between 1 and 2? Well, at first we might say, oh, those are enantiomers, because here we have a wedge, and then over here we have a dash, and here we have a wedge, and here we have a dash. So that should be the opposite configuration at both chirality centers. So those might be enantiomers. But let's go to the video to see if that's true. On the left is a model of drawing 1 with the 2 bromines coming out at us in space. On the right is a model of drawing 2 with the 2 bromines going away from us in space. And if I rotate the model on the right, we can see that these are mirror images of each other. But they are superimposable mirror images. If I put that one on top of the other, you'll see that they are superimposable. So these actually are 2 models of the same molecule. This is a meso compound. It's a compound that has chirality centers, but it is achiral. The mirror image is superimposable. So 1 and 2 really represent the same molecule. This is a meso compound, a compound that has chirality centers but is achiral. The mirror image is superimposable on itself. So we thought we would have 4 stereoisomers, but really we only have 3. We have a pair of enantiomers, and we have 1 meso compound. So to look for a meso compound, one thing you could do is what we did in the video. We had the mirror image, and we were able to superimpose the mirror image on itself. Another way to look for a meso compound is to look for a plane of symmetry. So if I draw a line here, think about this as being a plane, and look for symmetry on either side. So you can see it's symmetrical. I drew in the plane of symmetry with a dashed line here, but it's hard to visualize it. So up here is a better picture. Here you can see the plane dividing the molecule in half, And on the left side, we have our bonds here, and then we have our bromine going up and our hydrogen going down. The right side is symmetrical with the left side, so look for symmetry on both sides of the plane. Let's do another example. This one's a little bit harder than the last one. We know that we have two chiral centers, so that's a chiral center, and so is this one. So we would expect 2 to the second stereoisomers, so that's of course 4. So I'll put a question mark here again because we're not sure if we actually will get 4 stereoisomers. That's a maximum number. Down here I have the 4 possibilities, so I've drawn them out just to save some time. So we have 1, 2, 3, and 4. And let's examine the relationship between 1 and 2 first. On the left is stereoisomer 1, and I've left the hydrogens off the methyl groups and the OH just so we can see the models better. So here's our carbon chain, and we have both OHs coming out at us in space. And then for stereoisomer 2, here's the carbon chain, and we have both OHs going away from us. So I'm going to hold them in the way they are in the drawing, and I'm going to rotate the one on the right. And when I do that, we can see that these are mirror images of each other. But if I try to superimpose one on the other, so I'll just rotate this one back here and flip it over, you can see they don't match up. So the atoms don't line up here. So they're non-superimposable. Doesn't matter how you do it, I'll rotate it again, and we can see we can't superimpose our atoms. So these are non-superimposable mirror images of each other. These are enantiomers. And we could check for a plane of symmetry, so I could take one of these and I could rotate it so we have our hydrogens going away from us in space. And I look for a plane of symmetry, but I don't see one, so this is not a meso compound. So 1 and 2 are enantiomers. They're non-superimposable mirror images of each other. And we could have guessed that because if we look at our chiral centers here, so this one has an OH coming out at us, and then that one has it going away from us. This one has an OH coming out at us, and this one has it going away from us. We have opposite configurations at both chirality centers. Let's look at 3 and 4 next. So what is the relationship between these two? Well, at first, we might think these could be enantiomers because at this carbon we have OH on a wedge, and then here we have OH on a dash. And then here we have OH on a dash, and here we have it on a wedge. So that might be your first guess. But let's look at the video and let's look at the model sets to help us out. Remember, I'm leaving the hydrogens off the methyl groups and the hydrogens off the oxygens in the video just to help us see the molecule more clearly. On the left, we have a model of drawing 3. So here's our carbon chain with an OH going away from us in space and an OH coming out at us in space. On the right is a model of drawing 4. Here's our carbon chain with an OH coming out at us in space and an OH going away from us in space. So I'll hold the two models and we'll compare them. First, let's see if they are mirror images of each other. So I'll take the one on the right and I'll rotate it and I'll hold it up next to the one on the left. And now we can see that these two are mirror images of each other. So next, let's see if one is superimposable on the other. So I'll go back to the starting point and I'll rotate it around like that. And let's see if we can superimpose the one on the right, the mirror image, on the molecule on the left. And notice that we can. All of the atoms line up. So all of the hydrogens, carbons, and oxygens are in the same place. So this is a compound that has chirality centers, but it is achiral. The mirror image is superimposable on itself. So we should be able to find a plane of symmetry. So I'll just pick one of these models. It doesn't matter which one because they represent the same compound. And I'll rotate around so we can see a plane of symmetry. So right there is our plane of symmetry. This is a meso compound. So 3 and 4 actually represent the same compound. So this is one meso compound. So these two are the same, and we have one meso compound. It's not really obvious looking at these bond line structures that these represent the same molecule. So definitely get a model set and try this out for yourself. So we thought there might be 4 stereoisomers, but actually there are only 3. We have a pair of enantiomers and we have one meso compound.